Assalamualaikum warahmatullahi wabarakatuh. We are from CS11 student from class B. Today we are going to present MAT183. Our topic of presentation is techniques of differentiation. And this is my group members. First is Arif Daniel bin Muhammad Razif and me, Siti Nur Atira binti Ubi Zaidi and Warashidi bin Hashim. Okay, next, Arif will explain the question 1.
Assalamualaikum and hi madam. My name is Arif Daniel. I want to explain to you about meaning of differentiation. First, in simple terms, differentiation is mathematical tools that we use to calculate the rate of change. It tells us how fast one thing is changing to another compared to in at any exact moment. So in differentiation also have the concept of differential calculus is a concern about how one quantity change in relation to another quantity. So the definition of derivative can be approached in two different ways that are interpretation of tangent line and rate of change. In differentiation also contains the concept of derivatives, including the interpretation of tangent line, the definition of derivatives, techniques of differentiation, derivatives of trigonometric functions, exponential functions, and logarithmic functions, the chain rule, the implicit differentiation, and linear approximation and differentials. So I think that's the meaning of differentiation. So we move on to another question, 1b. Question 1b. List and explain briefly 4 common techniques of differentiation. So number 1, the sum and difference rule. So in this rule, tells us that calculus plays nice with basic addition and subtraction. If you have an algebraic expression with multiple terms added or subtracted together, you don't need to panic. You can simply differentiate each term individually, one by one, keeping the plus or minus signs exactly where they are. So here are the formula that I already learned. D over dx f x plus minus gx equals to d over dx f x plus minus d over dx gx equals to f prime x plus minus g prime x. So here are the first rule. Number 2 is product rule. So we use product rule when we have two different functions multiplied together. So here are the formula that I already read. Dy over dx equals to uv prime plus vu prime. So here are the product rule. We go to number 3. Number 3 is question rule. Question rule is used when functions are being divided like a fraction. It's like u divided by v. So the formula is dy over dx equals to v u prime minus u v prime over v square. So here are formula that we can use for the question rule. So we move on to the last rule that I have learned and in that techniques of differentiation. So last is the last is chain rule. In this rule, this is used for composite functions, or what I like to call functions inside other functions. To solve this, you differentiate from the outside in. You first take the derivative of the outer layer while keeping the inside expression exactly the same, and then you multiply the whole thing by the derivative of that inner function. So here is the formula that in the chain rule. Dy over dx equals to dy over du times du over dx. So I think that's all the 4 common techniques of differentiation. So thank you, madam.
Thank you to Arif because explain the question 1. Okay, my name is Rashidi bin Hashim. I want to explain the question 2. Okay, for the question 2, we see the question want to find dy over dx for the following function. Okay, for the question A, we have y equal to 4x power of 3 cosecant minus 5x. Okay, first of all, for 2a, you should use the formula product rule. Okay, first of all, you should find the u and v. For this question, u is 4x power of 3, v is cosecant 2 minus 5x. Okay, du over dx is 3 times 4, 12x power of 2. dv over dx is negative cosecant 2 minus 5x time cot 2 minus 5x time differentiate this, you can get negative 5. Okay, you can solve this answer. Negative 5 times negative, if you can get 5 cosecant 2 minus 5x cot 2 minus 5x. Okay, after you get the u v differentiate of v, you can use this formula, which is the product rule. Okay, you can write the formula dy over dx. dy over dx is u dv over dx plus v du over dx. Okay, after you write the formula, you just you just take this information into the formula. Okay, you got 4x power of 3 times 5 cosecant 2 minus x 2 minus 5x cot 2 minus 5x plus v, you get the cosecant 2 minus 5x times 12x power of 2. Okay, after you put the information into the formula, you can solve this. Okay, 4 times 5, if you can get 20x power of 3 cosecant 2 minus 5x cot 2 minus 5x plus 12x power of 2 cosecant 2 minus 5x. Okay, after you get the answer, you should to factorize this answer. Okay, how to factorize the answer is you take the 4x power of 2 cosecant 2 minus 5x times 5x cot 2 minus 5x plus, okay, that's the final answer. Okay, so done for A. Okay, let's see the question 2B, which is the B. Y equal to 2 power of 4 minus 10 x power of 2 over sine 2x. Okay, right, the question y equal to 2x power of 4 minus 10x power of 2 over sine 2x. Okay, so for this question 2b, you should use the question rule, formula question rule. Okay, let's answer the question. For you have 2x power of 4 minus 10x power of 2. V, you get the sine 2x. For du over dx, 4 times 2, 8x minus 2 times 10, 20x. 8x power of 3. Okay, for dv over dx, sine 2x. For this answer, you should differentiate. Use differentiate sine, you can get the cos 2x time, you should differentiate 2x. You differentiate 2x, you got 2. Okay, you solve this, you can get 2 cos 2x. Okay, after you get the uv du over dx, dv over dx, you should take this information into the formula, which is the question rule formula. Okay, for the question rule formula, we have dy over dx equal to v du over dx minus u dv over dx over v power of 2. Okay, let's take this information into the formula. Okay, we have sine 2x time du over dx 8x power of 3 minus 20x minus we have 2x power of 4 minus 10x power of 2. You can time with dv over dx 2 cos 2x. Okay, over v over 2, you get the sine 2x power of 2. Okay, after you put into the formula, you can answer the question, which is the sine 2x time with 8x power of 3. 8x power of 3 sine 2x minus 20x sine 2x minus 2 times 2, you can get 4x power of 4 cos 2x minus 10 times 2 10 times 2, you can get 20x power of 2 cos 2x over sine 2 power of 2 2x. Okay, after you get this answer, you can factorize the answer. How to factorize? Okay, you just take the number. Okay, 8 open bracket 8x power of 3 minus 20x close the bracket, you write the sine 2x minus, you write the 4x power of 4 minus 20x power of 2. Okay, and close the bracket, you write cos 2x over sine 2x. Okay, this is the final answer you get. Okay, that's all from me. I can pass to Atira for answer the question number 3. Thank you.
First of all, thanks to Rashidi for solving the first question. Next, I am going to solve the second question. So, this is the problem statement given e power of x cubed plus 1 minus y squared ln 5 plus 4x equal to 4 plus tangent to y. Find dy over dx using implicit differentiation. So, we know that implicit differentiation, there are 4 steps. Okay, first of all, we need to d over dx the equation, and I have already d over dx the equation. Okay, next, first step is we differentiate both sides of the implicit function with respect to x. Okay, next I'm going to differentiate the equation. This is going to be 3x squared e power of x cubed plus 1. Okay, I am going to hold this first, and then we move to this. D over dx4 is going to be 0 after we differentiate it. And then this tangent to y, tangent is going to be secant square 2y dy over dx. When we differentiate it, it's going to be 2 secant 2y dy over dx. Okay, so and then this actually y squared times ln 5 plus 4x. So this is suitable when we differentiate it using product rule. Okay, so this y squared going to be u, and ln 5 plus 4x is going to be v. And then this is the formula of product rule. So u is y square, u prime is 2y times dy over dx. V is ln 5 plus 4x. V prime is 1 over 5 plus 4x times 4. And then this is the answer after we differentiate it. 4 over 5 plus 4x. Okay. Okay, next we use this formula. Y squared times 4 over 5 plus 4x plus ln 5 plus 4x times 2y times dy over dx. Okay, so it's going to be 4y squared over 5 plus 4x times 2y ln 5 plus 4x dy over dx. Okay, next I'm going to put the equation that I have differentiate, and then it's going to be 3x square e power of x cube plus 1 minus 4y square 5 plus 4x plus 2y ln 5 plus 4x dy over dx equal to 2 second 2y dy over dx. Okay, step 1 is finished. Okay, next is step 2. Step 2 is we allocate the term with dy over dx on one side of the equation, which means that this part on the left side is the equation that have dy over dx, and the right part, the right side is equation that has no dy over dx. So step 2 is going to be like this. 2y ln 5 plus 4x dy over dx plus 2 second 2y dy over dx equal to 3x square e power of x cube plus 1 minus 4y square over 5 plus 4x. Okay, step 2 we are already done, and then next is step 3, which is we factor out dy over dx. 2y ln 5 plus 4x plus 2 second 2y dy over dx equal to 3x square e power of x cube plus 1 minus 4y square over 5 plus 4x. Okay, this is the step 3. And then the last step is we solve for dy over dx. Okay, which means that we bring this to here. Okay, so it's going to be like this. Dy over dx equal to 3x squared e power of x cubed plus 1 minus 4y squared over 5 plus 4x over 2y ln 5 plus 4x plus 2 second 2y. And then this is the final answer. This is how you solve this problem statement using to find dy dx using implicit differentiation. That's all from me. Thank you.
Thank you, Atira, for explain question 3. So let's move on to question 4. The question is use linear approximation to estimate the value of 4 root of 81.02 minus 2 over square root of 81.02 correct to 4 decimal places. So step 1, identify fx. So fx equals to 4 root of x minus 2 over square root of x. So we get x power of 1 over 4 minus 2 minus 2x power of negative 1 over 2. And then step 2, we differentiate fx to compute f prime x. So f prime x equals to we differentiate, so 1 over 4x, so 1 over 4 minus 1 equals to negative, so we get power of negative 3 over 4. So minus, when we differentiate negative 1 over 2 and we multiply 2, we get negative 1. So when negative 1, we get here plus. So here is 1x. So when we get negative 1 over 2 minus 1, negative 2. So step 3, we determine value of x and x0, then compute the change of value x. So x equals to 81.02 and x0 equals to 81, and then here x equals to x minus x0, so equals to 81.02 minus 81, and we will get so we get 0.02. Let's move on to step 4. After step 3, step 4 which we have to compute value of f x0 and f prime x0. So f x0 so equals to f 81, so equals to 4 root of 81 minus 2 over square root of 81. So we get equals to 81. So we get 25 over 9, and then we have to do a f prime x0. So f prime x0 equals to f prime 81. So equals to 1/4. We look at the step 2, that the f prime x. So 1/4 1/4 81 negative 3/4 plus 81 power of negative 3/2, and we get so we get 31/2916. Let's go to final step, step 5. So step 5 is we have to evaluate the estimation value of the function by using linear approximation formula. So step 5, so this is the formula. So f in bracket x0 plus of x, so f in bracket x0 plus f prime in bracket x0 sum of x maybe. So we insert the number. So the number is, we insert the number into the formula. So 25/9 minus 31 plus 31/2916, we times by that at the step 3 that we had done, 0.02, and we will get 25/9 plus 31/2916 times 0.02, and we get 2.77 277 8. So that's if want to check the answer maybe is correct or not. So that's we have to insert this one into the calculator. So 4 root of 81.02 minus 2 over square root of 81.02, and we get this maybe the same answer, 2.778. So I think this is the answer that this is the question is asked to 4 decimal places, and I think this is the answer. So, because the answer for this one, the answer for 25/9 plus 31/2916 times 0.02 is 2.77993398. So but the question asks for 4 decimal places, so I think the answer is 2.77 778. So I think that's all for me. That's the answer, I think. So thank you, madam.
In conclusion, we have walked through the comprehensive solution from question 1 to question 4. We can see how differentiation is not just about abstract rules, but is a powerful mathematical tool used to determine rates of change and perform accurate estimation in real-world scenarios. By mastering techniques like the product rule, question rule, implicit differentiation, and linear approximation, we build a solid foundation for more advanced analysis. We hope our explanations were clear and helpful. Thank you so much for your time and attention. And a special thanks to our lecturer, Dr. Hazwani binti Hashim, for the continuous guidance. Thank you and have a wonderful day ahead.